So it appears obvious that this brace, which is over here, needs to be over here. Needs to shift about an inch that way. Now the actual mounting device that mounts the indicator to the travel of the quill, I'm going to keep that. It's fine. Now the quill itself has a 5-inch movement. Now, of course, this is moving up and down as a unit because the brace here is, the bracket is not attached. So what I'm going to do is set the quill to half of its travel, or 2.5 inches. I'm going to determine total travel available in the indicator. It's a little more than 6 inches. And then set it to halfway, which means the quill will be in the center of its vertical travel, and the digital scale will be in the center of its vertical travel. So here's the quill at half travel. That's 2.5 inches. And full travel, the digital readout was 6.8 inches, so I have it set at 3.4, close enough. It's 5 thousandths off. These, of course, are paper binder clamps, like you would find in our office supply room. They're holding the scale vertically. This is the bracket I'm going to try to reuse. What I try to do is mount the scale back on the bracket. And I'm just going to use a set of binder clamps. Now I'm going to position this back part of the brace over the mounting holes. So it looks like we're going to have to move in the end clamp, the end brackets that hold the scale to this mounting bracket. To position the scale, the edge of the scale, about 30 millimeters. From the end of the bracket. So I've drilled new holes and mounted the scale, slid over this far. Now I need to determine the depth between this mounting bracket and the mounting position on the mill. I'm going to work this in inches. Looks like 0.596. This bracket is somewhat flexible at this point, so probably going to aim for a 0.6 thickness. I do have some in and out movement on the follower here. These number 6 screws are held on by nylon locking lock nuts, and I can make this one hit the frame of the machine. So out would be better than tighter. I think I'm going to use this, I believe it came from Banggood face mill. I haven't used it before. This is the original Schar's spacer bar that was to go up on the mounting bracket. It's about 1 inch thick right now. Take a touch here, probably go the whole way across. Then I'll set 0 on the knee. So there's 40 thousandths. I'm going to set the knee to 0. I'll measure the thickness of this. Looks like 839. Say 840. So we want to take 240 thousandths away. Go another, we'll set it at 50 thousandths. Another 50. So we did one pass of conventional milling and another pass of climb milling. Very nice finish, no problem at all. I'll take it down to another 2 50,000ths passes. It should take 2/10 off of the thickness of the material. So that takes us down to 641. So I'll take 41 thousandths off. Actually, I'm only going to take 40 off. This ring moves up and down with the spindle. And a little measuring device has an end on it that fits in this hole. That's how the measuring device tracks the spindle. To get maximum spindle travel, it's necessary during the last half inch. So for this little piece of metal to telescope inside, that means that this cannot go in past this, where the mill will stop here. That is, the black follower will stop on top of this instead of going the whole way to the bottom. Just something to think about. This block is the original spacer that this is the milled surface that I did here in the mill. I had to cut off this back corner because it was hitting this part of the mill. It needs to go higher. But the screws are bottomed out, this screw in the slot, and it won't go any higher. Now I did drill and tap. Well, the number 29 drill just coasted through. But I tapped at 832. And I'm using some stainless steel screws. So let me mount the indicator. I'm going to do that by pushing this the whole way down to make sure the spigot on the indicator doesn't go past this telescoping piece. Well, I think we're done here. I cut a metal shim the width of this mounting bar, about a 1/16 of an inch thick, and then I used it to space this bar out a 1/16 of an inch. That allows me to clear this telescoping piece. I don't know if you can read it, but I zeroed it at maximum travel, and I'm not touching any part of this frame. I'm actually the stop is up against the stop. And there we are at maximum travel, which is 8 thousandths, 9 thousandths over the 5-inch rated travel of the spindle. I guess we're done. And I can get the guys back when the virus is over, and we can finish some AR-15 low receivers. Now, I bought this from Shars. It was advertised as fitting at Bridgeport. It was the only one they had. Of course, they sell this loose. Really, it comes with 2 clamps at the top. It comes with 2 pairs of clamps. And then for extra money, you get this bracket and the aluminum spacer. I don't have a Bridgeport. This is an ENCO. ENCO's out of business now. They were bought up by Manhattan Supply, MSC, and MSC just ended using their ENCO trademark. This is a very similar mill to a lot of the Chinese mills. Shars may not have ever thought of making an adapter. It did take some work, but I don't personally think that's Shars' problem. I don't know if those numbers mean anything or not. Well, I think that wraps up this job. If you enjoyed this video, or if you want to see more, give me a thumbs up. Ask me a question, or better yet, subscribe. Thank you.